Hey. Oh, I can hear myself. Ah! Okay. Ah, shut up. Shut up. um. Hello. Hello, no one. It's me, no one. This is essentially a test to see whether this new microphone is worth every penny. Probably not, because it's only going to capture me. Yeah. So anyway, ooh, I don't know whether things are a bit loud. It sounds very good in these headphones. Very chilled, this music. Anyway, I'm going to play some Universe Sandbox, which I haven't really spent much time with yet, but space is awesome, and it might be a very cool thing to have a play with, at least to test out this old microphone. I might have to sing along though. Add some weird vocals. Anyway, okay, let's get going. Let's do something. Let's turn down the music slightly. Okay, right. So I've got things spinning around. Got Saturn over there in the distance. Hello. Big old sun there. There's us. Hey, look, camera's following us. Whoa! Hey, whoa! Look how fast we're spinning, man. That's worrying. I feel like spinning way too fast. What's happening? Anyway, I think we've got tutorials. I'm going to follow a tutorial. Because I don't talk. I don't know if I'm talking loudly or not. The little microphone occasionally shouts at me. Maybe I am talking too loud. Let's turn the music down slightly. La la. Okay, right. So let's go for a guide. Let's go on a journey together across the solar system and beyond. Maybe just the solar system. I don't know if I'm adventurous enough to leave the solar system. Okay. Welcome to Universe Sandbox. Oh, right. This thing keep coming up? It probably does. This is our solar system. Where do I live? I live here on Brexit Island. Whee! Okay, this is the Earth. It is home to everyone you know. It's true. I don't know anyone else from anywhere. And this is the sun. It is the most important source of fuel for life on Earth. It's very true. We owe everything to Mr. Shiny Sun Guy. Praise the sun. What have we got rid of it? Oh god. Tools. Delete. Delete the sun. Oh no. Oh no! Things are flying off. Oh no! Without the sun, our entire solar system falls apart. And Earth gets a little chilly. Whoa, we're already like frozen over. Oh god. Seems to be doing alright over here though. Australia's fine. Still got the electricity on. So the rest of us are frozen over. La la la. It might just be my headphones that are like loud. I'm trying to get the right balance, you see, between actual audio coming through on the computery stream thing and what's being funneled into my ear holes. Okay, Earth's a bit chilly right now. To rotate the camera, click and drag. To zoom in and out, use your mouse wheel. Whoa! This music is nice, it's very chilled. I could listen to this while I'm doing other things. No, not when I'm flying through the solar system. Okay, the Earth is very cold now. The Earth is very cold now, but maybe we can fix this by adding another source of gravity and heat. Alright, why not? I've got nothing to lose at this point. Pause the simulation while we work on a solution. Okay, paused. Paused it. Add a new star to the simulation. To add an object to the simulation, use the create tool. Add. Okay, let's go over to here, to stars. Rigel. Blue-white luminous supergiant. Spectral type. I can't even read that, it's too small. B8IA. Mass 21 of our suns. It seems a bit like it might be a bit overpowerful, I'm thinking, but let's see. Whoa! That's very pretty. Look at that. It's pretty. Rigel is very large star. It is 23 times more massive than our sun. Its gravitational force should be enough to bring back the planets. Okay, let's resume. Look at those little solar flare things going on. Very nice. Oh, Rigel's kind of... Where's he going? He's getting pulled by the other planets, I think. Oh god! I'm sucking up all of the dwarf planets. Ah! No! No! Oh, I've just destroyed Saturn. I've destroyed all life on the solar system. Oh no. Oh, Pluto's fine. So we cast away. Oh no, Earth's still going. Earth's still fine. We've got Venus out there. Here's Mars. I think it's because they were so far flung out before, but they are coming back now. La 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 la. Okay, this doesn't look right. All the planets have been sucked in. No! Oh, there's Earth gone. Okay, next. So maybe we made some mistakes and ruined our solar system. That's okay. There's always something to learn from an experiment, even one that ends in all life in the solar system being extinguished in a big blue fiery ball. Continue on to the next part of the introduction and learn about creating life-sustaining worlds. Or if you want to skip the introduction and start experimenting on your own, select home, close guide. Yeah, I'm going to go for the next tutorial because you've done a good job there. La 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 la. Yes, Rigel was too big for our solar system. I think we knew that. The planets didn't have enough velocity to orbit such a massive star. Turns out the sun is a good match for us. Yes, it is. There it is, okay. Here is the Earth that is orbiting much closer to the Sun than it should be. To see the Earth's temperature, look at its properties. Okay, clicked on the Earth. So, we've still got our regular mass. Oh no! Average temperature 130 degrees centigrade, 140. This doesn't look good at all. I die if it's pretty much over 20. It's been in my flat. Well, there was a heat wave recently, and it was like 28, 29 degrees in my flat, and I died multiple times during that period. To change a property, click its text box, type a number on your keyboard, then press enter. Okay. You can also use multipliers or drag the slider. That's 267 degrees centigrade. Feels a little warm to me. Maybe we should try to bring it back down to like room. Oh god! It's now frozen. Stop. Oh god. That made it cooler for a little bit, but its temperature's still rising because it's so close to the sun. That's true, it's going back up again. Whoa! It takes time to heat up the Earth and start boiling its oceans. Even this close to the sun will speed up the simulation so you don't have to wait that long. Oh, thanks. Now take a closer look at the Earth. Focus the camera, click on it again. Zoom in. Whee! Oh wow, that doesn't look like beautiful green and blue that it was before. It looks a bit grey and yellowy, dead. I presume, is this like this little ocean? Was the ice cap? A little bit there. After 6 years of orbiting this closely to the sun, the high temperatures have caused the Earth's oceans to boil away. Without water, Earth can no longer support life. Oh no. We all knew it was going to end this way. Okay. Fortunately, in reality, Earth is already in the perfect position. Yes, it is. It's in the Goldilocks position. Not too warm, not too cold, just right. This second Earth is orbiting at its actual distance from the Sun. It is what's known as the Sun's habitable zone. Okay, we click on View. And there's a little habitable tab. Oh, look at that. We've got two Earths going on. One in the nice, comfortable green zone. One in the black death zone. The green area represents the Sun's habitable zone. This zone shows where the temperature is just right for liquid water on a rocky planet like Earth. In the red zone, temperatures are too high, and in the blue zone, temperatures are too cold. Average temperature on Earth is 8 degrees centigrade. Oh, that's interesting. I didn't know what the average temperature was on Earth. The average is 8. Interesting. 8's pretty cold, but it's not too bad. I could survive at 8. It's perfect for liquid water, you see. We're learning things here, or at least I am. Ay, ay, ay. It says I've got one viewer, but that must be me. Because it would freak out if someone's watching me just babble on about nothing. Our planet may be in the right place to allow life to thrive, but small changes can still have a massive impact on our climate. We've learned using this scientific method, a process that involves careful observation. We've learned this using scientific method and the process that involves careful observation and analysis. And it has allowed us to explore the depths of space. Continue on to the last part of the introduction to explore simulations of astronomical missions and discoveries. Or, if you want to skip right to experimenting on your own, select Home, Close Guide. Now I'll go to the next one, please. Ooh! Look at that! The hell? Using what we learned from science, we've been able to accomplish the seemingly impossible. Whoa! This is Voyager. In 1977, we launched the Voyager spacecraft to explore the gas giant Jupiter. Voyager continues its missions today as it journeys into the interstellar space, carrying a golden record that's of sounds of the Earth. Oh, there's Jupiter. Hello. It's big. It's pretty big. Hey, come back. Come back, Jupiter. Ooh. I mean, how amazing would it be to, you know, also terrifying, but be able to fly around and see these things. Obviously, I don't know the speed in which this Voyager's travelling in this simulation, like 1 billion miles an hour, but it'd be pretty cool. We've discovered potentially inhabitable planets farther away than we can imagine. Here, in the TRAPPIST-1 system, more than 40 light years away from us, we've observed 5 planets that are similar in size to Earth. Hello. You're a very red-looking thing with a weird green glow. I don't know what that's about. Ooh. It's pretty cool. And right now, somewhere on this small planet, a small team are busy building a universe simulator that makes it easy to launch a moon at the Earth. Oh no, that sounds... doesn't sound right at all. Earth, moon. Oh no, we have to... have to fire... Okay, I'm gonna fire... the moon at the Earth was I'm gonna go for the ocean. I'm gonna try to not to pick on anyone. Holy moly! Oh well, I've pretty much wiped out life on Earth anyway. Oh wow! Look at all these huge chunks of Earth. Oh god! No! Well, bit of rain, I'll sort it out. Oh no, there's another bit of rock! Oh no. There's more coming! Look out! Oh, have we missed that one? No, it's still coming. It's still coming for us. Oh no! There's nothing we can do! South America, alright. Has that caused... I don't know if that's weather or like an ice age of just... No, it couldn't have caused an ice age of them destroying the planet. Such a cool... such a cool simulation. here you can ask really big what-if questions that you couldn't answer in real life. Going back. Like, what if the sun disappeared? Or what if the earth was too hot? Or what if the moon came hurtling towards us? All things I spend many a night stressing about. Or even, what if the Milky Way collided with the Andromeda galaxy? In the universe Sandbox, you create, destroy, and explore on a scale you've never before imagined. Oh god, look at these universes. Not universes, solar systems collide. Galaxies, what am I talking about? Oh wow, holy crap. These black things, the supermassive black holes at the center of our galaxies. Guessing so. Oh, wow, that's some crazy shit. Wonder where we are in all of this infinite stars and space and planets and moons and asteroids and meteors and stuff. One last thing while these galaxies collide. Click home. Home is the starting point for everything in the universe Sandbox. Click guides. If you ever want to learn more about using the universe Sandbox, select the topic here. I want you to guide me through the rest of it, please. Click the back arrow. Open existing simulation. Here you'll find simulations like the ones we just saw, plus many, many more. We hope you enjoy exploring and experimenting in the universal Sandbox, universe Sandbox. Don't add extra letters to words. Oh well, okay. Tidally locked Earth. What's that then? Tidally locked Earth. In this simulation, Earth has recently been tidally locked with the Sun. The Earth is now rotating once per year, so that one side of the Earth will always be facing the Sun, and the opposite side will always be facing away towards the darkness of space. The side facing the Sun will heat up until the ocean is nearly boiling point of water. On the other side, the snow will pile up on the ocean and eventually freeze. Open the Earth's surface tab or multiple data views to watch how Earth's temperature on the surface changes over time. Average temperature is rising. Oh no, it's not. It's falling. That's a minus. So yeah, tidally look. I'm sure like the moon's tidally locked with us. So like we only ever see one side of the moon. The whole dark side of the moon thing is not true because we don't produce sun. The sun is somewhere else. So the moon's always, one side of the moon's always facing us, but the other side of it still gets sunshine. Like when we get a lunar eclipse, we only see the black outline of the moon when the sun's on the other side. So essentially the dark side of the moon is the light side of the moon at that point. Something like that. But wow, space is awesome. Space is awesome. It's so big and spacey. But where are the aliens? Ooh, Earth at 1,000 degrees centigrade. 1,000 degrees centigrade is roughly the temperature of lava. Holy crap. Heat the Earth to this temperature and its surface will begin to melt. And the ice caps melt, and the amount of liquid water in the ocean will first increase, then eventually decrease as it falls away. Meanwhile, the Earth will slowly cool as its heat is lost into space. Ah, I see, because we haven't got like an atmosphere to keep it in anymore. I guess it all just evaporates into space. Wow. That's it's quite a pretty looking thing. I wouldn't want to live here at 1,000 degrees centigrade, but it's very pretty. I like the colours. Wow. Whoop. Very cool. What's this one? What? Holy crap. Ah! Oh no! No! I think it was called Earth and like a sphere of moons. That's way too many moons. Look at the damage it's caused. Something super chill. Oh, it's the music as well. The music's really chill, but like just watching these celestial bodies just kind of like dance around each other and then smash into each other and explode. It's very cool. Cool is the word I'll keep using. Oh no! No! Oh god! No! Earth exploding at a close moon. In this simulation, the moon circles the Earth on a very close orbit. 30 minutes into the simulation, the Earth explodes, sending fragments in all directions. The moon's surface is heated as it collides with some of these fragments without the Earth's gravity to maintain its orbit. The moon flies off into space in a straight line. Yeah, where have you gone, moon? Come back. There he is. It's like a huge hit and run. Oh look, it's still a bit warm though from Earth. Wow, that was some dramatic shiz. I might need to go for that again. Oh what, that's another one. Sun and exploding Jupiter. In this simulation, Jupiter circles the Sun on a very close orbit. 30 minutes into the simulation, Jupiter explodes, sending the fragments in all directions. These fragments continue to orbit the Sun. I think I saw Professor Brian Cox's one of his things. It's probably like Wonders of the Solar System. He's talking about the rings of Saturn. I can't remember exactly how they got there now. Was it that something might have collided with Saturn and like sent up debris, and it just ended up like neatly turning into this big disc at some point, and it's all like ice or something. I don't know, but it's very impressive. the 100-year anniversary of the eclipse that validated general relativity. On May 29th, 1919, a total solar eclipse was visible in parts of South America, Africa, and the Atlantic Ocean. Astronomers used this event as an opportunity to test Einstein's theory of general relativity, which predicted that light from distant stars would be bent by the gravity of the Sun, making them appear in a slightly different location than Newton's model would predict. Two expeditions of astronomers, one to Sobral, Brazil, and one to the island of Principe. I can't, it's too small for my eyes to see. Principe, off the coast of Africa, used telescopes and photographic plates to measure the positions of stars near the Sun, which were visible during the eclipse. The results confirmed Einstein's predictions, making headlines around the world and bringing international fame to Einstein and his work. This simulation shows the 1919 eclipse that was used to test Einstein's theory. General relativity is not included in the physics simulation behind Universe Sandbox, but even if it was, the difference in observed star positions between Newton's model and Einstein's model is extremely small, about 1/2000th the width of the full moon. Glad we've got, glad we did have folks like Einstein and Newton and all those geniuses to kind of figure out what's going on and how the universe works. La 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 la. Ah! Wolf and oh god, what's happening? Wolf 369, a red dwarf star, is 7.8 light years from our own solar system. In this simulation, however, the Earth crashes directly into Wolf 359 and is swallowed up by the star, which swells in size due to the increase in its internal temperature from the collision. Da, 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 da. Earth and Earth. Oh no! Oh look, we make another Earth, but to join two Earths together and create loads of tiny moons. Actually, quite big moons. That are going to come crashing down. Guess what goes up comes down. Must come down unless it's in like a perfect circular rotation, and then it's essentially always falling, but in a nice way that doesn't collide with us. Oh dear. Is this thing coming for us? Oh. Ah, jeez. Systems. Earth and 100 colliding moons. Oh no. Oh wow. Other moons that look like tiny Earths. If you could watch it from a safe distance, this happening, and not be obviously like vaporized and instantly, you'd get a good amount of YouTube views, I think. Whoa. Asteroid Volatile test. In this simulation, 50 asteroids, each with a radius of 20 kilometers, orbits the Sun at distances that range from 2% to 125% of the distance between the Earth and the Sun in our solar system. The Sun's gravity pulls volatile materials like water from nearby asteroids. The speed of the volatile loss depends on the distance between the asteroid and the Sun. So is Earth somewhere? Oh wow, look at that. Ooh. Whoa. It's pretty. How many times Asteroid 1 has been around the Sun at this point? It's quite a few. Oh wow. Wow, okay. So we've replaced our Sun with Beetle Juice. Beetle Juice is one huge mother, and of course that means it's going to swallow everything up real quick. Has Earth already been swallowed? Looks like. What would happen if the Sun was replaced with the red supergiant star Betelgeuse, or Betelgeuse, whatever you want to call it? Mercury, Venus and Earth and Mars all have orbits smaller than Betelgeuse's radius, so these rocky planets are swallowed up instantly. Jupiter soon follows, as Betelgeuse's higher gravity pulls the rest of the solar system planets and objects. Wow, look at the size of that guy. I want a simulation of what happens when when the Earth enters its when the Sun enters its red giant phase and swallows everything up. They must be on here somewhere. Let's do a search. Sun, red. Red giant might be the wrong name for it. Let's just go for Sun. Let's just try this. Whoa! Supernova, the Sun in solar system. Our Sun will never experience a supernova due to its low mass. It will eventually evolve into a red giant, there you go, and then a white dwarf. However, in this simulation, a supernova is triggered in the Sun, sending an expanding cloud of gas outwards into the solar system. This could reach the Earth within an hour of the supernova. Within 6 hours, it just reached the orbit of Jupiter. Within 24 hours, the cloud is expanding to the outer reaches of the solar system. Wow. So, it looks like obviously it won't ever go. The sun won't ever go supernova, but it looks like it would just take out Earth, Mars, Venus, Mercury in an hour? What's this? Oh wow, are they like, is this like a real gravitational pattern that can happen? Wow, that's so cool. Oh no, everything's breaking out now. It's like a spirograph. Oh. So cool. Although they seem to like bounce off each other rather than explode. What time is it? Cool, well, I should probably disappear again, because I'm sure, even though this is very chilled and I like it, I should probably make sure that everything works. This is kind of a test. But, yeah, wow. It's like the coolest, most fascinating game ever. Milky Way, the Milky Way galaxy, you are here. Also known as the Silver River. I didn't know that. I didn't know it's called Silver River. The Bird's Path. Oh, that. Oh, the Winter Street. No, never heard those names. And countless other names throughout human history. It is the home of the solar system, Earth, and every known human in the universe. A barred spiral galaxy. The Milky Way has 4 spiral arms. Yes, it does. Composed of hundreds of billions of stars and planets, but appears from our point of view inside one of the arms as the bright band of light across the night sky. In very dark viewing conditions, dark dust lanes are visible silhouetted against the stars and the gas that makes up our home. So it sounds, what, are we in one of these arms then? And then when we look out into the night sky, sometimes we see a band of all those stars. And I like, that shit's awesome. I'm going, whoa! Can't get into this black hole, unfortunately. Oh, it's spinning. Supermassive black hole. Right, let's see one last thing that looks cool. Grids. Earth exploding in real time. Oh! Holy heck. In this simulation, the moon circles the Earth on its normal orbit. 2 seconds into the simulation, the Earth explodes, sending fragments in all directions in real time. A simulation speed of 1 second per second. It takes 1 second per second is real time. It takes over 12 hours for these fragments to reach the moon's orbit. The moon's surface is heated and collides with some of the fragments, and without the Earth's gravity to maintain its orbit, the moon flies off in a straight line. Yeah, so I guess that background there, that's what it looks like, I guess, when we're... If you live somewhere that I don't, if you live somewhere with a nice clear night sky, you can probably see shit like that. Ain't she pretty? Cool, right, well, enough exploring space for today. I'll go now and test that this actually recorded. Goodbye.